In this question, we have a baseball pitched horizontally and 0.145 kilogram. It's pitched at 27 meters per second and it strikes bat. And then after collision, it changes the direction and goes up. And then it goes straight up to a height of 31.5 meters. And we know that the contact time is 2.5 milliseconds. And we're trying to find the average force between the ball and the bat. So from this, you can see that the formula we should be using is just Newton's second law. It's F times delta T equals the change of momentum, which is just the change of velocity, because again, m is constant, and we know the delta T. And if we're trying to find F, we already know m. What we need to know is what is the change of velocity for the baseball. So there are a lot of things we need to convert. So at first it's going horizontally, so we only have this horizontal velocity. But afterwards, it goes straight up, so we only have this vertical velocity. So you can see there is a change of direction here. And so the change of horizontal velocity is negative 27 meters per second, because it doesn't have any horizontal components after the collision. But we need to know what the vertical velocity is. So now we need to go back to our very first kinematic problems. We have initial velocity is going up, and with the gravitational acceleration acting downward, it moves a total of 31.5 meters. Let's just use, there are a lot of ways to solve this, but let's just use conservation of energy for now. So right after the strike, the kinetic energy is half of mvy squared. And when it's at the very top, it has no kinetic energy, but it has a potential energy of mgh. So from that, we can cancel m, and we get Vy equals square root 2gh. And that gives us 2 times 9.8 meter per second squared, that's the gravitational acceleration, times the total height, 31.5 meter. And that is a total of 24.85 meter per second. So pretty much after it hits the bat, it acquires a vertical velocity of 24.85. So then we have delta Vy is 24.85 per second. So that is great. Now, with these two numbers, we can find Fx is m delta Vx over delta T. And that is 0.145 kilogram times 27 meters per second over millisecond is 0.0025 second. Let's make sure we all use SI units. So that is it's negative 1566 Newton. And Fy, delta Vy times delta T, we're plugging the same number. Is 1441 Newton. So yeah, now here negative just because I defined this to be the positive direction. So that means the force is acting this way and up. So pretty much you can see the force is acting around the perpendicular direction. Maybe not completely perpendicular, but it's roughly acting in this direction. And yeah, that's the two components of force. And so let's try to find the total force. So that's, again, just a little bit geometry. It's equal to fx squared plus fy squared is z square root. And that gives us around, this is 2128 Newton. Again, just to make sure we have the same amount of significant digits, we have about 2100 Newton. So that is the total force. And if we're not satisfied, we can try to find this angle. So now we have an fx and an fy. We can try in total of f. We can try to find, say, this angle. It's called theta. That is the angle from horizontal. And we have tangent theta equals fy over fx, absolute value. So if that is 41 over 1566. So if you have a calculator and you just do theta equals arc tangent this number, you will get theta around 42.6 degree or 43 degree. So that's the magnitude and the direction of the force we're looking for.